Two random variable x and y have the following joint probability density function. F of x comma y is equal to 2 minus x minus y, where x lies between 0 and 1 and y lies between 0 and 1. Find the marginal probability density function of x and y. Next one, find the variance of x and variance of y. And third bit, covariance between x and y is equal to 2 minus x minus y, and the limits are given as 0 less than x less than 1 and y also lies between 0 and 1. Okay, and it is 0 otherwise. Now what is the first bit? It says the first bit it says to find the marginal probability density function of x and y. Okay, in order to find for x and y, I have to let us first consider for the x. Okay, in order to find the value of x, how do we find? The function f of x is equal to integration over the limits minus infinity to plus infinity, the function f of x comma y into dy. Whenever we are finding the marginal function of x, it is taken with respect to y. This is the important point we need to note down. Now next thing is the limits of y is given over here in the question as what? From 0 to 1. So my limits are from 0 to 1. What is the function f of x comma y? It is 2 minus x minus y into dy. Now I need to do the integration with respect to dy. So I'll be getting as 2y minus x is a constant over here. So x into y minus integration of y will fetch me as y square by 2. And what is the limits over here? 0 to 1. Okay, now let me substitute the upper and lower limit in the case. So when I substitute the upper and lower limit, I'll be getting as 2. I'm substituting the upper limit in all the y terms. Okay, my x terms will be as it is. 1 square is 1, 2 minus lower limit is 0. So automatically it will be 0. Next is 2 into 1 is 2 minus x minus 1 by 2. This will give me what answer? 2 into 2 is 4. 4 minus 1 is 3. So this is 3 by 2 minus x. Now what is this value what I have got? This is for the marginal function of x. Okay, now I have obtained the marginal function of x. Next is I need to find the marginal function of y. Marginal function of y. The formula is f of y is equal to integral over the limits minus infinity to plus infinity function f of x comma y d of x. Over here when we are finding the marginal function of y, we need to take with respect to x. Now I need to substitute the value. Over here the function f of x comma y, what it is given in the question, it is given as 2 minus x minus y into dx. What is the limit of x given? The limit of x is given in the question as from 0 to 1. Now in the similar manner what we have done for the case of x, same as that. Over here we are doing the integration with respect to x. So 2 into x minus integration of x is x square by 2 minus y is a constant term into x. Okay, over the limit from 0 to 1. Next term I need to substitute the upper limit as well as lower limit. Now if I substitute the upper limit, that is 1 in x, I'll be getting as 2 into 1. 1 square is 1. 1 by 2 minus y is as it is in x. In minus, if I substitute the lower limit, I'll be getting as 0. Now next is 2 into 1 is 2 minus 1 by 2 minus y. So this will fetch me as what value? This will give me as 3 by 2 minus y. Now what I got the marginal function? My marginal function what I have obtained is f of y is equal to 3 minus 2 minus y. This is the marginal function of y. Now the next bit says to find the variance. In order to find the variance, the formula is variance of x is equal to expected value of x square minus x of x whole square. Okay. Now in order to find this, we should first find what is the value of e of x. Then we can square it, right? So in order to do that, first we'll find what is e of x. Now e of x is also called as mean or expected value. So what is the formula for it? It is integration from minus infinity to plus infinity x into f of x into dx. This is our formula. Now over here we know that we have already found the value of f of x. What is the value of f of x? The value of f of x we have found is this x is as it is. The value of f of x that I have obtained is from my problem previous bit is 3 by 2 minus x. This dx is as it is. Now this we are doing with respect to x. What is the limit of x given in the question? From 0 to 1. So I'll multiply the value of x with that of this expression. So I'll be getting integration 0 to 1. This is 3 by 2 into x minus x into x is x square into d of x is as it is. Next step what I'll be doing, I'll be integrating with respect to x. So I'll be getting as 3 by 2 x square by 2 minus integration of x square is what? X cube by 3 over the limit 0 to 1. Okay, now if I substitute the upper limit and lower limit, I'll be getting as over here 3 by 2. I'm substituting the upper limit in x. So 1 square is 1 into 2 minus 1 cube is 1 by 3. Okay, lower limit is what? 0. So anyway it is 0. So now when I solve this value, what I'll be getting? This is 3 by 4 minus 1 by 3, which will fetch me the value as 5 by 12. This value of 5 by 12 is for what? This value is for e of x. That means my mean value is 5 by 12. Now we have already obtained the value of e of x, that is mean value. Now the next is we are supposed to find the value of e of x square. Now in order to find e of x square, the formula is integration from minus infinity to plus infinity x square into the function f of x of dx. Okay, now integration, what is the limit of x? The limit of x is from 0 to 1. My x square is as it is. The function f of x value, what we have obtained, we have already obtained the value as 3 by 2 minus x into dx. Again we should do multiply the two terms. We'll be getting integration from 0 to 1. This is 3 by 2 x square minus x cube into dx. Now I'll do the integration now. The integration of this is 3 by 2 x cube by 3 minus integration of x cube is x power 4 by 4 over the limits 0 to 1. Now what is the upper limit and lower limit? I'm substituting the upper limit in x, so I'll be getting 3 by 2. When you substitute the value, I'll be getting as 1 by 3 minus 1 by 4 minus 0. Okay, so this value, this 3 and this 3 will get cancelled. we are left with 1 by 2 minus 1 by 4. So this will give me the value as 1 by 4. Now this value is what we have obtained as e of x whole square is 1 by 4. Now what the formula for variance, as we know, variance is we have already calculated the values e of x square minus e of x whole square. Okay, now variance is given as e of x square minus e of x whole square. The value of e of x square, what we have got? We have got as 1 by 4 minus e of x, how much we have got? In the last bit we have got as 5 by 12 whole square is equal to 1 by 4. If I square this, I'll be getting as 25 by 144. So after solving, I'll be getting by 1 by 16. This is variance of x. Similarly, I need to calculate the variance of y. Now, the variance of y is easy to calculate since it is same as that of our variance of x. And since the values are same, we can just write it. Now, similarly, e of y is same as that of our e of x, that is e of y is 5 by 12. Next is the value of e of y square. E of y square is nothing but 1 by 4. And the variance of y will obtain as 1 by 16. This is similar to that of finding the variance of x. Now, the last bit says to find covariance. It says to find the covariance of x comma y. In order to find the covariance of x comma y, the formula is expected value of e expected value of xy minus expected value of x into expected value of y. Okay, the formula is covariance of x comma y, that means it is for two variables, is e of xy minus e of x e of y, expected value of xy minus expected value of x, expected value of y. We have already found the value of this particular value, expected value of x we know, expected value of y we know, but we don't know the expected value of x and y. So how do we find expected value of x and y? The expected value of x y can be obtained as double integration. We have the limits for x as what? 0 to 1. For y, what limit? 0 to 1. Over here, x y into the function. What is the function given in the question? The function that is given is 2 minus x minus y dx dy. The formula generally, how do we write it? Expected value of xy is nothing but double integration of xy into the function f of x comma y dx dy. Now our function is given over here is this one. Now I should do it separately. Okay, now let me just multiply each of the terms. Fine, so this is 0 0 1 1, this is 2 xy minus this is x square y minus xy square dx dy. I need to integrate this separately. Okay, now if I just integrate first with respect to y. Okay, now with respect to y, if I integrate, what I'll be getting? Integration 0 to 1 as it is. With respect to y, I'm integrating. So over here, what is my 2x is a constant term, y will be there. So integration of y is y square by 2 minus x square is a constant. Integration of y is y square by 2 minus x. Integration of y square is y cube by 3 over the limits what 0 to 1. We need to still do with respect to x as well. Now we'll first substitute the limits of y such that it will become simple for us. So 0 to 1 as it is. In place of y I'm substituting 1 upper limit, so I'll be getting as 2x. In place of y 1, if I substitute, I'll be getting as 1 square. 1 square is nothing but 1, that is 1 by 2, minus this term will be x square. In place of y I'm substituting what 1, so 1 square is 1, so 2, minus x. In place of y again I'm substituting the upper limit, so it is 1 by 3 into dx. Anyways the lower limit 0 will fetch me the value as 0, so no need of writing it once again. Okay, now I need to integrate with respect to x. So when I integrate it, I'll be getting this 2 and this 2 will get cancelled. Integration of x is what? X square by 2, minus integration of x square is what? X cube by 3, okay, into our previous value 2 as it is, minus integration of x is what? X square by 2, and my 3 values as it is. Upper limit is what? Upper limit is 1, lower limit is 0. Now again I'll substitute the upper and lower limit. I'll be getting as 1 by 2 minus 1 by 6 minus 1 by 6. Okay, so this will be 1 by 2 minus 2 by 6. So this will reduce to as, this is 1 by 3. So the answer I'll be getting as 1 by 6. Okay, now this is what value I have obtained. I have still just got xy value is equal to 1 by 6. Okay, now I have my value of all the terms. For finding the covariance I have all the terms now. Covariance of e of xy I have now, e of x I have, e of y I have. So what I'll be doing, I'll be substituting the values in my formula. So covariance of x comma y, this is my formula. I'm writing it once again. Expected value of xy minus expected value of x, expected value of y. Now what is the expected value of xy? What I have got, the expected value of xy I have got as 1 by 6, minus the expected value of e of x, what I have got from my previous bit, 5 by 12, and this what I have got, 5 by 12. Okay, right. Now if I solve, this is 1 by 6, this is 25 by 144. Now when I solve this, I'll be getting as 24 minus 25 by 144, which will give me the answer as minus 1 by 144. This is the covariance of my x comma y. Okay, in this bit we have done all the different bits we have calculated.